Hi folks, thanks for joining me. Today, I'll be showing you how to mix agar media and pour Petri dishes for DIY mushroom cultivation. First, I'll go over what you need and what you need to know. Then, we'll talk about sterilization, pouring, labeling, and storing your Petri dishes. Plus, I'm going to throw in lots of handy tips, tricks, and techniques that'll help you keep your fungus happy. Of course, feel free to skip ahead to the juicy stuff by using the chapter markers, or just sit back, relax, and enjoy joining me on yet another journey into the wonderful world of DIY mycology.
Never give up.
Working with agar plates is what I would consider to be an advanced mushroom cultivation technique. If you're new to mushroom cultivation, I would encourage you to start the same way that I did, keep it simple, keep it easy, and use a liquid culture syringe in conjunction with a grow kit. That way, you can get a good handle on the process by starting at the end, the part where you're growing the mushrooms. Once you're comfortable with that, you can start to add layers of complexity.
Oh, I remember back when I was a young lad, naive, before I had my sea legs, and we were in there shaving our nipple hair. We scrubbed every inch of that ship from bow to stern. We kicked our roommates out. Not even the rats were spared. Sterilizing that poop till 4 in the morning. Shoplifting flats of mason jars. Making PF Tech with brown rice we found in the trash. Swashbuckling with dirty syringes we bought for cash in the mail. And half of them went bad and the other half went bad later. I can only imagine if back then someone had told me that someday you could just go to truebluegenetics.org and buy yourself some perfectly clean, vigorous liquid culture for just a few dollars. Boy, I think I'd probably tell you, I've heard of such the place as El Dorado. But I tell ye, the winds of fortune will never smile on you quite the same as when you go to truebluegenetics.org and use the coupon code BLOGGER to get yourself 20% off on your liquid culture.
You really don't need to work with agar when you're beginning your mushroom cultivation journey, and I find that sometimes people can get discouraged because they try to add too much complexity to their process too early on. That said, once you feel like you've gotten comfortable with all of the different parts of the process, from grain spawn, spawning to bulk substrate, and the whole fruiting stage, then it's time to work on those more advanced techniques, and your next step is working with agar. The overall process I'll be describing in this video involves mixing agar media in a media flask or a jar, sterilizing it in a pressure cooker, and then pouring it into pre-sterilized Petri dishes. I'll touch briefly on how to sterilize reusable plates, some tips on labeling and storage, but before we get into all of that, let's get a little bit of background information. I'll pass the torch over to Professor Sporadicus. Petri dishes themselves are just clear, shallow containers. They have a loose-fitting lid that's easy to remove and replace, and when sealed, they can be kept sterile while still allowing us to observe the growth of the microorganism inside. They're also stackable, which allows us to keep a huge diversity of different organisms in a very small space. Now, just about any container that you can sterilize can be used as a Petri dish, but there's a few things to note. One, we want to make sure that we can easily get access to that agar media, so we don't want a deep jar. It's also worth noting that professional, purpose-built Petri dishes have some little pegs that will help create a little tiny bit of space for air to flow past the lid. Then, once we're done using these, we'll tape them off with a wax tape called parafilm. At that point, the mycelium inside can still breathe, but it remains totally sealed off from outside pathogens. The other reason vented Petri dishes are important is because they allow us to completely blow off all of the condensation which can form on the upper part of the lid after we pour the hot agar media inside. Condensation can pool up and create standing water in our plates, which can create problems for our fungus. As a side note, this is why it's also important to keep your Petri dishes in a temperature-stable environment. If the temperature fluctuates a lot throughout the day, condensation will also form inside of the sealed Petri dish. Agar itself is a gelatinous substance that's extracted from certain types of seaweed. When it's mixed with water, heated, and then cooled back down to room temperature, it creates this firm but kind of jello-like substance, sort of like a vegan jello. By adding different ingredients to our agar, we can adjust proportions and make the perfect recipe for all kinds of different work with plants, fungi, and bacteria. For growing our mushroom-producing species, we use a high agar ratio that creates a firm two-dimensional surface for the mycelium to extend horizontally. The same process can be used for culturing plants, but we use larger vessels and a softer media so that the roots can easily penetrate. One quick side note. I get a lot of people asking me about no-pour agar technique. This involves mixing the agar media into a reusable Petri dish and then sterilizing it with the agar already poured. This way, you don't have to open and pour the Petri dishes, which seems like it would help you keep it a lot more sterile. While I'm sure many people have success with this technique, I don't personally recommend it because in my experience, it causes a lot of problems with condensation forming on the inside of the Petri dishes that then creates standing water in your plates, which can create a real problem for the fungus. Overall, condensation is a major consideration when it comes to pouring agar plates, so we'll be talking a lot more about that in a later section of the video. All right, let's talk about supplies. First, we're going to need to get some Petri dishes. A lot of people use a lot of different kinds of things as Petri dishes. You can use baby food jars. You can use those little plastic sauce ramekins that you get from food trucks. Most of us use clear plastic disposable Petri dishes that come pre-sterilized in a sleeve. There's a link in the description that'll show you where to find those on the cheap. However, if you're a purist, you can also purchase reusable Pyrex Petri dishes. These are incredible. They are, however, very expensive. I think it's worth mentioning right off the bat that what I'm going to show you in this video is a sterile process, which means we're going to need a sterilizer and we're going to need to create a sterile workspace. As for sterilizer, you'll come to find that I'm really quite fond of my antique Presto canners. And for a lot of folks who are starting out, especially for pouring agar, an Instant Pot is a really great option. It's set it and forget it, and I'll be covering that in my upcoming video on pressure cookers and sterilization. As for creating a sterile workspace, there are a number of different ways we can go about doing this, but by far the best option is to use a sterile air filtration device called a laminar flow hood. I make a small portable flow hood that's meant to be affordable and ideal for beginners. I'm also working on a video on how to build a full-size unit for a fraction of the cost of buying one new. But if you're just starting out and you're not ready to take the plunge, you can also simply use a working flame. I like to use an alcohol lamp. I also discuss this in much more detail in my video, Mycology Lab 101. Next, you're going to need a vessel to mix and sterilize your agar media. Now there's something that is made specifically for this purpose, and that is a borosilicate media flask. These are very, very high temperature resistant, thick glass bottles with a super thick polypropylene cap. The idea is that these are designed to withstand the pressure that it's going to be under in our pressure cooker. I want to say a few things about these. I used to think that I needed to use something like this to pour agar plates, and I've actually completely moved away from them altogether, and I'll tell you why. For one thing, when you're pouring, because it has such a wide lip, it's actually a lot harder to pour cleanly without agar dribbling down the outside of the jar. When you have drips while you're pouring, that can create problems. The main reason that people use these is because you can fill them to the top, seal them, and pressure cook them like that. I never do this, and that's because if there's any kind of failure, the jar will boil over and it'll make a huge mess. The other thing is even these super thick bottles will, on occasion, explode under that much heat stress. After running into some problems with leaky lids and having one of these explode on me, I started only filling them halfway and then leaving the lid vented in the pressure cooker. That way, it wouldn't boil over while it cooked. Then I realized if I'm doing that, I might as well just go ahead and use a regular canning jar. And I find that actually the lip of the regular mouth mason jars, not the wide mouth, are a lot easier to pour with and a lot cleaner than even the media flasks. I like to use these plastic polypropylene canning lids, but you don't even need to use that. Even just a piece of aluminum foil is enough to cover the jar because we're gonna unload it from the sterilizer and pour it while it's still hot. Now, as again, I cover in Mycology Lab 101, there's a lot of other things you're gonna wanna set yourself up with, like a bottle of isopropyl alcohol, some nitrile gloves, a surgical mask, paper towels. I also sometimes will like to use a stir plate. This is a magnetic stir plate with a stir bar that'll sterilize in the agar, and it'll make it easier to mix it while I'm pouring my plates. That way I get a nice even pour. This isn't necessary. You can mix it manually. Just use one of these if you have it. Don't go buying a new one just for this. You'll also definitely want to have some Sharpies and some masking tape. These are great because you can label your jars, sterilize them, and when you remove them, you can still read the label, but you can also peel it off and reuse the jar for something else. You'll also want a measuring cup for measuring your water, and I always like to grind up my ingredients using either like an old coffee grinder or a magic bullet. You'll find that most agar media recipes use mass rather than volume to measure the ingredients, so you'll need a scale, preferably one that's accurate at least to the 1/10 of a gram. Next, let's talk about ingredients. This is where it starts to get fun. Obviously, the most important ingredient in your agar media recipe is agar. Agar, sometimes called agar powder, is extracted from certain types of seaweed, has a lot of culinary uses, and it's also used widely throughout the biological sciences for growth media. This is because you can heat it and then cool it down, and it creates a firm, stable surface. There are a lot of different grades of the quality of agar. When we're using it for culinary purposes, you can get pretty low-grade stuff and it's quite cheap. However, once you start going towards high-end bacteriological grade or lab-grade agar, it can get pretty expensive, and it's not necessarily processed any better. The main thing is we don't want chemically processed agar. I've gone through a lot of trouble to find a really good source of agar, which I bottle and sell on my website at fungia.life. And of course, if you want to skip all of the trouble of sourcing your own ingredients and making your own recipes, you're certainly welcome to buy my premix on there as well. On its own, agar offers very little nutrition. It's really just there to create the growth structure. So we get to decide what we're going to feed our fungus. Now, just like you probably don't want to be kept in a dark room and fed nothing but Mountain Dew your entire life, our fungi really don't want to eat the same thing all day, every day. It's also really important to feed them novel food sources in order to challenge their metabolic capacity and prevent what we call senescence, which is genetic decline. Varying our agar media recipes is not only a really important part of keeping our fungus happy and healthy, but it's also a great way to train it to eat novel food sources, to clean up pathogens and wild specimens using antibiotics, for example, or to teach a fungus to figure out how to metabolize specific toxins like motor oil or pesticides. That said, you can really get away with just using 2 ingredients in your agar media. The first being some kind of simple sugar or carbohydrate, and the second, and the most important of all, as always, is water. I personally think that it's really important to have a good, clean source of water. I like to use filtered spring water. You can use tap water, but at least run it through a charcoal filter if you can. Of the many different types of sugar that work well in agar media recipes, you'll find that most of us in the DIY mycology world rely almost exclusively on light, dry malt extract. This is in part because it's relatively inexpensive and it's very simple short-chain carbohydrates that are extremely easy for the fungus to digest. It also offers a little bit more nutritional complexity than some of the other simple sugars out there, and it just works. The other sugar you'll sometimes see me use in my media recipes is corn dextrose. This is also just another really simple sugar. Both of these can be purchased from your local brewery supply store. There are 2 other ingredients that I use in almost every media recipe, and those are nutritional yeast and a little bit of gypsum. Beyond that, there's a lot of different directions we can go, but don't worry, this isn't a French sauce. You don't need to follow a strict recipe, and in fact, I really encourage you to just play and enjoy the process of cooking a fine meal for your fungus. This is where my approach tends to differ from traditional practices, and I believe that it's important for each of us to develop our own intuitive understanding and relationship with our fungus. In my opinion, this is the real difference between the science and the art of mushroom cultivation. As you can see, I've laid out a lot of different ingredients here, but please don't feel like you've got to go getting everything on the list. The main thing that I think it's really helpful to think about is that anything that you use in any part of the mushroom cultivation process as a food source for your fungus is a great amendment for your agar media. For example, whatever type of grain you're going to be using for your grain spawn is a perfect thing to add even just a small pinch of. By the time you then move that fungus into the liquid fermentation stage and finally into that grain spawn, it'll remember how to eat it, and you'll notice a significant difference in its leap-off time. Before I get into specific recipe ideas, I'd like to just talk briefly about what some of the jars on the table are and why I like to use them. One of the first things you might notice is that many of these ingredients are different types of grain. I sell liquid culture for a living, and so I like my customers, regardless of the type of grain that they're using, to experience the benefit of that trained fungus when they put it to their grain spawn. Grain offers a lot of nutritional benefits, a lot of variation, and regardless of what kind of fungus you're growing, almost all traditional cultivation approaches involve grain at some point in the process. There are a lot of different popular choices out there. Some folks really love to use cornmeal. Brown rice flour is great if you're doing PF Tech. Don't particularly recommend it, but a lot of people love that method. Millet is a really great option for super fast colonization times. Sorghum is also closely related and has a similar benefits. My personal favorite is rye. If you're interested in this, you can check out my video on how to make your own grain spawn, where I'll go a lot more in depth in all of the grain choices and how to prepare them. Now, if you're growing dung-loving mushrooms, adding a little bit of manure to your agar media will help it recognize that food source later on. If, on the other hand, you're growing hardwood-loving mushrooms, like oysters, for example, you might grow those on wheat straw, so adding a pinch of straw to your agar media will really help it recognize its food once you transfer it into that final substrate. This is also why I use a little bit of hardwood sawdust, and here I have a friend who's a wood turner, and he just has big bales of it, and I'll grind it up into a sawdust that's probably 10 or 15 different types of hardwood. I think this is fairly intuitive that adding substrate ingredients to your agar can be helpful, but there are a few kind of weird ingredients that I really like to rely on from time to time. One of those is charcoal. This is activated charcoal that's specifically made from coconut husks, but really any food grade or nutraceutical grade activated carbon or even homemade hardwood charcoal is a really, really fantastic ingredient and will make a jet black agar that makes really dramatic contrast with the white mycelium as those plates grow. We call these recipes blogar. The other one that's a little out there, I thought was pretty weird, but I figured I'd just give it a try, and I've found that it actually results in some pretty impressive growth, is dog food. I have a dog. I love just grinding up a little bit of her food and throwing, not often and not a lot, but a little bit of dog food into one of my recipes as a way to reinvigorate and challenge specifically those fungi that have been in cold storage for a really long time, and I'm trying to wake them up and get them moving and active again. I also always like to add at least just a little bit of gypsum or calcium sulfate. This adds an elemental sulfur component that's a really important part of the biochemical tools that fungi use to fend off pathogens and break down novel food sources. It also acts as a pH buffer. Now, if this is your first foray into mushroom catering, I recommend that you just start with one jar, pour a few plates, and see how it goes. But pretty quickly, you're going to want to expand. It's a lot of trouble to mix and sterilize all of this, so you might as well do as much as you can all at once. I can fit 7 1-quart mason jars in my Presto canner, so I say why not make it a banquet and we'll cook our fungus a 7-course meal. As you'll recall, we don't want to fill the jar all the way, or it's going to boil over in the pressure cooker and create a huge mess. I find that I can fill my jars to about 750 milliliters to get the most out of my pressure cooker run and pour a lot of plates at once. But today, just to keep it simple, I'm going to show you these recipes based on a 500 milliliter batch of agar. The first and most obvious ingredient is the agar. We use exactly the same proportion in all of our media recipes, and that is 20 grams per liter. Since we're doing half a liter, that means we need 10 grams in each jar. For our first course, we'll be trying out a very simple recipe, and that is malt extract agar. That's just light, dry malt extract, which you can get from your local brewery supply. For all of my recipes, I'm going to be using a baseline of 2% for my sugar solution. This is the same that I use for liquid culture, and I'll vary it slightly if I'm adding more or less carbohydrates like grains, for example.
For this recipe, I'll just use 10 grams of light, dry malt extract. I'll add a pinch of gypsum and a pinch of yeast.
The second most common recipe for most DIY mycologists is potato dextrose agar.
For this, we'll use 8 or 9 grams of corn dextrose and some dehydrated potato flakes, which dissolve nicely. pinch of gypsum, pinch of yeast.
Now, enough with this common fare. Those dishes are pretty bland, so for our next course, I think we should spice it up a bit. This is my very favorite recipe, and I use it or some variation of it for most of my agar media. That is the grain train. Not only will adding a lot of different grains help train our fungus to be able to metabolize those later on in the grain spawn stage, but it also has a lot of nutrition and a really good variety.
As usual, we'll start off with some malt extract. Let's go with about 8 grams this time, since we'll be adding a lot of other goodies. Rye is always my favorite, so I'll add a hefty pinch of that. Sorghum is also quite lovely. And millet is another great choice. Wild bird seed, rice, corn, oats, wheat, whatever you have lying around. Finish off with a pinch of yeast and a pinch of gypsum.
Now, if you're growing the wood-loving mushrooms, another great recipe to try is saw and straw.
This time, let's go with an even 5 grams of malt and 5 grams of dextrose.
Didn't talk about.
Then we'll toss in a medley of our favorite hardwoods and some shredded organic wheat straw. And you guessed it, little gypsum, little bit of yeast.
Don't tell anyone. But this is the secret ingredient.
By now, I feel like you know the drill. I say, why not put a little bit of poop in there?
For our next course, let's try something weird. Dog food agar.
For this one, let's go with a straight 10 grams of dextrose. And I'll add about 2 grams of ground dry dog food.
When I first started making agar media, I thought I had to be really precise and follow recipes to the letter, and over time I've come to realize that it's actually really good to just play with it and experiment, try a bunch of different stuff. One great way that you can add some variety to your agar media is just use some of the byproducts in your home kitchen. For example, if you're cooking potatoes, use the water that's left over at the end for your potato dextrose agar. For our last recipe, let's just be playful, let's be loose, we'll throw in the whole kitchen sink. This is also where I'm going to show you how I like to use one of my very favorite agar media ingredients, and that is activated charcoal. This makes a jet black agar, and that's why we call it agar.
All right, for this one, you might want to start taking some notes, because we're going to be putting a little bit of this in there, putting a little bit of that in there. We're going to be throwing in some of the other things, and a little bit of those, and I mean, we're just going for it, man. I mean, this is it. We're really doing this. This is where it all happens. This is the sauce. This is the bread's butter right here.
All right, now we've measured out all our ingredients. It's time to get cooking.
We'll carefully measure out our water, adding 500 milliliters to each jar. Mix the ingredients thoroughly until the agar and the sugars are completely dissolved. Make sure to get any clumps that might have stuck to the bottom of the jar. If you're using a stir plate, now's the time to add your stir bar. Loosely cap the jars. If you screw the lid down and seal the jar, pressure will build inside during sterilization, and it'll either blow the lid off or it could even crack the glass. Then cover each one with a piece of aluminum foil. This provides an additional layer of protection when handling the jars after they've been sterilized, and it also helps contain the mess if one of the jars boils over inside the pressure cooker. If you're using baby food jars, glass plates, or some other reusable vessel as your petri dish, leave the lids loose and then wrap them in aluminum foil and sterilize them alongside your agar media. If you don't have enough room for all of it in your pressure cooker, make sure to sterilize your plates first. Otherwise, your agar media could start to cool before your petri dishes are ready. Next, prepare your pressure cooker for action. Use a rack to keep the jars off the bottom, ideally one that keeps them out of the water. I add 1.5-inch stainless steel carriage bolts to my pressure cooker racks to leave plenty of space. Add water to the pressure cooker according to the manufacturer's specifications. This is usually about 2 quarts. Carefully load the jars and arrange them evenly in the pressure cooker. Double check that the caps are still loose. Put the lid on your pressure cooker and leave the steam vent open. Place it over high heat and wait for the water to come to a full rolling boil. Once it begins to hiss, allow it to vent steam for a few minutes to release all the air inside before placing the regulator weight on top and letting it start to build pressure. Once the pressure cooker reaches 15 psi and the shaker weight starts to rattle, turn down the heat and set your timer for 45 minutes. Try to avoid cooking it any longer or you risk caramelizing the sugars, making them inedible to the fungus. Babysit your pressure cooker and make sure it stays hot enough to continue releasing steam intermittently, but not so hot that it rattles constantly. If you're new to using pressure cookers, make sure to read the directions carefully and check out my upcoming video on the topic. Once the time's up, turn off your pressure cooker and allow it to gradually cool. If you take the weight off too soon, the rapid change in pressure will cause the agar inside to boil over and make a mess. When using a laminar flow hood, you can move the pressure cooker just before it reaches atmospheric pressure, place it in front of the flow hood, wait till it fully depressurizes, and then unload the hot jars using heat-resistant gloves. Otherwise, just leave the jars to cool inside the pressure cooker for about an hour before opening the lid. Wait for the agar to cool enough that you can hold it without getting burned. Depending on the size of the batch, this usually takes about 45 minutes to an hour. While you're waiting, this is a great time to start preparing your Petri dishes. If you're using pre-sterilized disposable Petri dishes, start by wiping down the plastic sleeve with isopropyl alcohol. Notice which side is which and cut the sleeve open from the bottom. Holding the stack so that no lids fall open, turn it over and squeeze the plates out like toothpaste from a tube. Keep pressure on the plates as you go to keep them closed. The sleeve that the plates came in will be useful for storing them later, so roll it up carefully to preserve its sterility and tuck it aside until the end. If you sterilized reusable plates or jars, you can just unwrap the foil when you're ready to pour. For your reference, I rarely use more than about 40 plates per liter of agar on average. You'll want to start the pour as soon as you can comfortably do so because there's a limited window to pour the media. Once it reaches about body temperature, it'll start to gel up and you'll be too late. If this does happen, you can try putting it back in the pressure cooker for another 5 minutes or so to become molten again. To avoid confusion, I should mention really quick that I filmed this next part using a different batch of agar than the one you just watched me measure out in part 1. I'll be pouring these plates using sterile technique in front of a laminar flow hood. You can also do this at home with just an alcohol lamp as a working flame. Check out my video Mycology Lab 101 if you'd like a refresher on how all that works. Before you pour, mix the agar by swirling the jar, or using a stir plate if you have one. We want to mix the media thoroughly, but we also want to avoid sloshing it, because if we make bubbles in the liquid, they usually won't pop. So, as they cool, they'll be cast in the agar and make some strange shapes. Uncap the jar and get ready to pour. With the jar of media in one hand, take a stack of plates in the other. I find it's best not to start with more than about 10 plates at a time. You can always stack more empty ones on top as you go. Pouring in a stack is quick, clean, and the plates insulate each other as they cool, which mitigates condensation issues. Starting from the bottom, grab the lid of the first Petri dish and lift the whole stack up and back. Pour enough agar to completely cover the whole bottom of the Petri dish, but be careful not to go past about the halfway mark. When agar plates are too thick, the fungus gets smashed against the lid. The mycelium is mostly growing horizontally, so the media can be pretty thin. I usually aim for around 1/4 of an inch, maybe a little less. With practice, you can get quite fast at this, but while you're starting out, take your time. Be mindful of drips. You can twist the jar at the end of a pour like you would when pouring a glass of wine. Drips on the table are fine, but drips on the sides of the Petri dish are difficult to wipe off cleanly, and they can create problems later on. Continue pouring your way up the stack until you get to the dregs of the jar. A 500 milliliter batch usually makes around 20 plates. Once you've poured a full stack, slide it gently out of the way, but move slowly. While it's still in a liquid state, it's easy to slosh the agar inside the plates and you'll end up with annoying flakes and chunks once it cures. Here's a great time-saving tip I picked up from Trad Cotter in his wonderful book Organic Mushroom Farming and Mycoremediation. I keep a jar of various colored Sharpies nearby and I create a color code for each agar recipe. I run the Sharpie up the whole stack of plates all at once, making a stripe on each Petri dish. This way I know what recipe was used without having to write it on each individual plate. This is especially useful when you're trying out new ingredients, testing cereal dilutions, or using specialized media like hydrogen peroxide agar, for example, which I'll show you next. Whenever I'm cloning wild specimens, I'll often run the mycelium on a cleaning plate to ensure it's free of unwanted stowaways before preparing it for cold storage. The method I prefer for this is hydrogen peroxide. Hydrogen peroxide has a variety of uses in mushroom cultivation because it quickly destroys mold spores in single-celled organisms, but mycelium, which produces its own peroxides, can neutralize it with little consequence. A small proportion of peroxide in your petri dishes is also a useful precaution against contamination if you're working in less than reliably sterile conditions. I just use the regular 3% hydrogen peroxide that you can find at any old drugstore. I use a sterile syringe to suck up a few milliliters, then carefully measure it into the agar. I usually only need to make a few at a time, so I'll pour all but the last 100 milliliters of agar to make the math easier, then add 1 milliliter of peroxide for a total concentration of 0.3%. If you want to be adding it to all your plates, I'd recommend using a little less, like maybe 1 milliliter to 300 milliliters of agar, which would be 0.1%. The most I would recommend trying is 0.5%. Use a stir plate or swirl it as thoroughly as possible. I've come across many folks who recommend using antibiotics in your agar to prevent contamination. However, I personally avoid this practice as I'm wary of the long-term impact that it may have on the fungus. Hydrogen peroxide leaves no traces or lingering effects. The only downside is it has to be added to the agar right at the end, just before pouring the plates, or else it just cooks off. Another method for cleaning up wild cultures is to use water agar, which is just water and agar, with no sugars or other food sources. The mycelium runs across it quickly in thin, wispy strands, drawing on its stored nutrient reserves to find something to eat. If you clone from the leading edge of this mycelium, it rarely brings any bacteria or other pathogens along with it. Once you've poured through all your jars, spread them evenly across your laminar flow hood, or in a circle around your working flame, and allow them to dry. If you don't allow the condensation to blow off, it will eventually lead to water beating up on the lid of your petri dishes, which can roll off into little puddles of standing water in your plates. After about 30 minutes, the windward side of the plates should be dry. Spin the stacks around, and then let them dry for another 30 minutes on the other side. As I mentioned at the beginning of the video, one of the many virtues of using different agar media is that it challenges the fungi and helps them keep their metabolic pathways open. This is an important part of preserving specimens long term and preventing genetic decline known as senescence. I like to make this easy by shuffling the deck. Before bagging them, I collate my plates into stacks of 7, one of each recipe, so that whenever I grab a few from the stack, they're always going to be different types. Once they're all dried and sorted, I'll tuck the plates back into their sterile sleeves and save them for later. I make the stacks 3 plates short to leave some free space in the plastic bag. I slide the sleeve over the top, then, keeping pressure on them to hold them shut, I flip the stack over and roll the opening down tightly. I fold the corners in and then hold them there with a piece of masking tape. This makes a very secure closure. With the leftover plates, or if you are using reusable petri dishes, you can store them in an unused, previously unopened Ziploc bag. I've been pleasantly surprised to find that these bags are consistently sterile out of the box, and will protect the plates for months until you're ready to use them. At this point, I've poured many thousands of plates, and I can count on one hand the number of times petri dishes have been contaminated in the bag. Regular resealable sandwich bags work great for 3 or 4 plates, and if you're going to do a lot, I find that a bag 6 inches wide will make a snug fit around standard 100mm plates. Store your petri dishes at room temperature. You'll want to keep them in as stable an environment as possible to avoid condensation issues. If this is a challenge in your environment, a cooler may be a good option for storing and incubating. All that's left now is a bit of cleanup. I like to let the remaining agar gel up in the jars, then toss it in the compost or the trash. Pouring molten agar down the drain is asking for a clogged sink. I use a bottle brush to clean the jars. When it dries, agar is a real pain to scrub off, so I always try to get it done right away. Of course, if you're a slacker, you can always just go with the old let it soak approach. Now you're all stocked up and ready to get growing. Pouring your own petri dishes can seem intimidating at first, but once you get the hang of it, it's really very simple and quite fun. Plus, it's incredibly rewarding to watch mycelium enjoying a meal that you've so lovingly prepared. This is a beautiful way to deepen your connection with your fungus. And at the end of the day, it's putting in the love that makes all the difference.
Well, folks, I hope this has been helpful so far, and I look forward to catching you on our future video about how to manage and build your mushroom culture library, where I'll talk a lot more about senescence, about preserving genetic vitality, and all sorts of incredible ways that you can preserve fungal specimens for years to come.
Well, my friends, now that you're ready to set sail, take it from Captain Agar. The best way to get yourself started with your mushroom cultivation journey is to go visit truebluegenetics.org. And don't forget to give me a shout out and say, hey, it was Captain Agar that sent me with the coupon code BLAGAR. Arr.